So we're looking at question 3 from the Pre-Calculus Mac 1140 Piecewise Functions with Domain and Range worksheet. It is asking us to, given the graph, find the piecewise function. So let's go ahead and analyze our graph. So looking at our first function, which is a cutoff piece of a parabola, we can see that this is a parabola because it has the point 0, 0, 1, 1, and 2, 4. And we know that a parabola without any transformations, which is x squared as a function, will produce this because 2 squared will get you 4. 1 squared will get you 1, 0 squared will get you 1, and if we continue this on the right-hand direction, it would continue that way. But we know that it has a restriction on its domain. So we know that the restriction is going to be any x value that is less than or equal to 1. We know this because there's a closed dot on the 1 value on the x-axis. So we know that 1 is included and it continues on in the negative infinity direction, which is less than 1. So that is going to be our first function. So let's go and label that. We have function 1 of our piecewise function. F of x is equal to x squared if x is less than or equal to 1. Now looking at our second one, we have a line. We know that this is going to be a y equals because it is a horizontal line. It's going to be y equals 3, and the restrictions are going to be given that x is less than 2, less than or equal to 2, but greater than 1. And we put that it's just greater than 1 because there's an open dot on the 1, but there's a closed dot on the 2. So our second function is going to be f of x is equal to 3 if x is greater than 1, but less than or equal to 2. So lastly, looking at our last function, we see it is a line. So this is going to follow the y equals mx plus b format. So we need to find our slope. Given that we have 2 points already, we have a point at 2, 2, we have a point at 3, 3, we can use our formula y2 minus y1 over x2 minus x1 to get our slope. So let's plug into our corresponding values to get that slope. We have that our slope is 1. So this is going to be 1x or just x. And our b, if this would continue going on, would be at 0. So you don't have to put a plus 0 or anything, it's just that. So we know that our second function would be y is equal to x. And it is restricted. And its restrictions are going to be that x has to be any number greater than 2. Not equal to 2, greater than 2. Because it is, again, an open circle. So let's write our third function. So now that we have those written out, let's go ahead and rewrite them over here with our a. Now that we have our piecewise function, let's go ahead and find the domain and range. So we know, looking at this, that our domain continues infinitely on in the left-hand direction due to our parabola. So this is going to be parentheses, negative infinity, and it goes all the way until, so we have a 1 here, we have an open dot and a closed dot, so this checks, this is included in it. Then we have an open dot and a closed dot, so this, again, this works because it has definition there, then it continues on right in the positive infinity direction. So we know that it goes on until infinity. Now, looking at our range, reading from bottom to top, it starts at 0. There's no other point below it, so it is going to be a bracket, 0, and it goes all the way up in the positive direction until infinity. Well, all the way through infinity, not until. So that is going to be our domain and range. Let's rewrite it over here. And now it is asking us to solve for f of negative 4 and f of 5. So we're going to go ahead and use our piecewise functions that we determined off of our graph and determine what these values are. So looking at our restrictions for f of negative 4, we can see that negative 4 is going to be less than 1, so it's only going to fall into our first function's guidelines. So f of negative 4 is equal to negative 4 squared, which is 16. Now let's look at 5. 5 is going to fall into our third function because it follows that restriction. So f of 5 replace dx with 5, and that is going to be our final answer, so it's just 5. And that is number 3 worked out. Now we go on to number 4, which has the same directions. We're going to define our piecewise function by looking at the graph, find domain and range, and then solve for some given variables. So, looking at our graph, we know that we have 2 functions instead of 3 because there's only 2 lines. So let's start with our first one, which is this one. We know this is automatically going to be a y equals, because it's a horizontal line. It's going to be y equals 1 with a restriction. The restriction is going to be that x has to be less than -1. And it's not less than or equal to because it's an open dot, not a closed dot. Now, looking at the next function, which is a parabola, it's been shifted down 3 units. We know that this is going to be a y is equal to x squared function. Now, we know that it doesn't have anything changed to the actual x argument because we still have our point that's going to be -3, 1. We have our point that's going to be +2, +1. So we know it's just been shifted down 3 times. So that's going to be a -3 attached onto that function. And we have a restriction, which is going to be x is going to be greater than or equal to -1. And it's again or equal to because this is a closed dot, so it is defined. Now that we have those, let's go ahead and rewrite them. So let's go ahead and find the domain and range now. Looking at our graph, the domain reads on the x-axis all the way to -infinity. So that's going to be principally -infinity. And all the way to the right, it has no break right here because you have a defined function where there is also an undefined function. So this reads all the way to +infinity. As for the range, reading from bottom to top, we can see that the range starts at -3, and that is going to be a bracket, and it goes all the way through +infinity. So that's going to be +infinity parentheses. Now we're going to solve for f of 4 and f of 0, and I'm going to use my restrictions and my piecewise functions that we found to do this. So f of 4 follows our first restriction set. Now f of 4 follows our second piecewise function because 4 is greater than -1. So we're going to plug in our value. We're going to have 4 squared minus 3, which gets us 16 minus 3, which becomes 13 as our final answer. Now for f of 0, this is still falls into our second function because x is our x value, because 0 is greater than -1. So again, 0 squared minus 3, 0 minus 3, this gets us -3. So that is number 4 completely worked out.